right, so our first example here is just to go ahead and complete the example from our introduction video to independent populations. So, anyways, this should look familiar. So, unless you haven't watched that very first video, I recommend that you do. But let's go through the 5 steps that was presented in the previous video on the test statistic and the p-value. So let's just note that our null hypothesis then is mu1 minus mu2 is equal to 0, where in our intro video we define the Midwest states to be mu1, and in our southern states this is going to be our second population. So the question here asks, does there appear to be a difference? So there's our keyword difference. Notice it's not asking is the Midwest bigger or smaller. It just says, is there a difference? So this means that our alternative hypothesis, mu1 minus mu2, then is not equal to 0. So this is step number 1. So step number 2 is to compute the test statistic and the p-value. So let's just recall, since we're in 2 independent hypotheses, we're going to use our t-test statistic. And this is going to be x bar 1, which is 16.23, minus x bar 2, which is 17.65, divided by the square root, open bracket, of S1, which is 4.06 squared, divided by N1, which we can easily see 1, 2, 3, 4, 5, 1, 2, 3 is 15, plus S2, which is 4.42 squared, divided by, and notice we're missing 1, so this is going to be 14. Okay. So again, performing the computation here. So we get 16.23 minus 17.65. Right, press enter. Then divided by the square root. And again, open bracket, 4.06 squared, divided by 15. Close that, plus open. So 4.42 squared, divided by 14. Close, close. I don't know what's the problem here. There we go. So we get negative, let's just say 0.9. So our t-test statistic is equal to negative 0.9. So then our degrees of freedom is going to be program df. Okay, there it is on the screen. Now we'll run it. So 4.06 and N1 is 15. And population 2, so 4.42. And then 14. So our degrees of freedom here is 26. All right, so then step 3 is to compute the p-value. So let's just note that we are on a t-distribution centered here at 0. All right, and to the left we get negative 0.9. So we get this shaded region here. And now we have to supply 0.9, which is going to be this upper tail, to get all of that. So this tail area here, okay, this tail area is our p-value. So this is going to equal to 1 minus the TCDF of our lower bound, which is negative 0.9, comma, 0.9, comma, and then our degrees of freedom, which is 26. So to get these two tail areas, this one and this one, notice all we have to do is go 1 minus this middle area right here. And that's exactly what we're doing, just kind of using a little bit of complementary probability. Or you could just compute this tail area and then double it. All right, so let's go ahead and go 1 minus. All right, and then second distribution, and then our TCDF menu option 6, so negative 0.9, comma, 0.9, comma, 26, close. So we end up with 0.3764. So this is 0.3764. So now our step number 4 is to make a decision. So notice that we have our p-value of 0.3764, and we have our alpha level over here, which is at the 5%. So we got to compare that to 0.05, and we can easily see that the p-value is much bigger than 0.05. Since the p-value is much bigger, we fail to reject. So let's just recall that when we fail to reject, we are not saying that the null hypothesis is true, nor have we proven the null hypothesis. All this means is that there is not enough evidence in the data to support the alternative hypothesis. Since we failed to reject the null hypothesis, notice that what we're saying is that the alternative, our null hypothesis states that there is no difference in the mean vehicle miles traveled between the Midwest and the South, and that's exactly what our data is indicating to us. So as our conclusion, we can state that at alpha equals 0.05, the data indicates that there is no difference between the vehicle miles traveled in the South is any different than the vehicle miles traveled in the Midwest. All right. So we have our second example here. So what I would encourage you to do is to, again, pause the video and try to work this one out yourself. And then once you get it done, you know, I'm going to put the solutions up here for you. So go ahead right now and pause the video. Okay, so coming back over here, it is very nice to know which is going to be our first population and which is our second. So just for sake of brevity and time, I'm just going to say that fraud is going to be population number 1 and firearms is going to be population number 2. So let's just note that step number 1 says to state the null and the alternative. So null is always mu1 minus mu2 is equal to 0, and the alternative, well, notice it says, do the data provide sufficient evidence to conclude that the mean time for fraud is less than that of the firearms? So this one here is going to be mu1 minus mu2, then is less than 0. Okay, so mu1 is less than mu2, so writing this as a difference, mu1 minus mu2 is less than 0. So step number 2, step 2 is to compute the test statistic and the degrees of freedom. So let's just note that our t-test statistic here is going to be 10.12 minus 18.87 divided by the square root of 4.9 squared divided by 10 plus 4.64 squared divided by 10. All right, so coming over here to our calculator, so we get 10.12 minus 18.87, and now divided by the square root, again, open bracket, 4.9 squared divided by 10 plus, open bracket, 4.64 squared divided by 10. Close, close. So we get negative 3.777. And let's just note that our degrees of freedom, so we'll come over here, program, DF, gets on the screen, starter on up, so 4.9, 10, 4.64, 10. So we get 17 degrees of freedom. All right. So let's just note that step 3 is to compute the p-value. So drawing our t-distribution. So here is our t-distribution on 17 degrees of freedom. And let's note that by our alternative hypothesis, this is going to be a left-tailed test. So we get negative 3.777. And this to the left is going to be our p-value, which is going to be TCDF. And this is going to be open bracket negative E99, comma, negative 3.777, comma, and 17 degrees of freedom. So we can compute that. Again, coming over here to second distribution. All right, so TCDF, menu option 6, lower bound, so negative, and then there's the E, so second E, 99, comma, negative 3.777, comma, 17. So I come up with, notice this, notice the p-value can never be bigger than 1, ladies and gentlemen. If you ever find a p-value bigger than 1, 7.52 is not going to work. You better be coming over here, and notice that this E negative 4 means to move the decimal place to the left 4 decimal places. So notice we get 0.0008. All right. So step 4 is to make our decision. So 0.0008, and we want to compare that to our alpha level of 0.05. And notice that this is way smaller. Way, way, way smaller than our alpha level. So here we will reject the null. We have a very, very, very small p-value. So this means that there is strong evidence to support the alternative hypothesis. So the alternative hypothesis has a lot of evidence for it. So again, we can come back over here and note that we did not prove the null alternative hypothesis. We didn't demonstrate it to be true. We didn't prove it. All we're doing is saying that the data appears to support the alternative hypothesis. So at alpha equals 0.5, the data indicates that the mean amount of fraud offenses is smaller than the mean amount of, or the time served for fraud is smaller than the time served for firearms. Okay, So that's our conclusion here. And notice that since that p-value is so small that concerning ourselves with committing a type 1 error, we don't really have to worry about that because of the 0.0008 is far removed from 0.05. All right, so here's our last example. Okay, my last example here. Again, I would encourage you to pause the video at this point in time and do this on your own and see what you come up with, and then come back and start the video to check out your solutions. All right, so researchers conducted a random double-blind study to measure the effects of this drug olanzapine on patients diagnosed with bipolar. Does the evidence suggest that the experimental group experienced a large mean improvement? So I am going to, for sake of argument and brevity, claim that our experimental group is going to be mu1 or population 1, and that our control group is going to be population 2. All right, so our step 1 is always to state the null and the alternative. So step 1 is going to be mu1 minus mu2 is equal to 0, and the alternative hypothesis is that the experimental group experienced a larger improvement. So that means that mu1 minus mu2, so let's note that we can start off with mu1 is bigger than mu2, bring the mu2 over, and we can easily see that this is going to be mu1 minus mu2 is greater than 0. All right, so step 2 is to compute the test statistic and the degrees of freedom. So let's just note that our t-test statistic then is equal to, let's see, 14.8 minus 8.1 divided by the square root of 12.5 squared divided by 55 plus 12.7 squared divided by 60. All right, so this is going to equal to, all right, so 14.8 minus 8.1 divided by square root, and then open, so 12.5 squared divided by 55 plus 12.7 squared divided by 60. So I get 1.15. So our degrees of freedom, so again, program, degrees of freedom, it's on the screen. Let's start her up. So S1 is 12.5 and 55 for N1 and 12.7 for S2 and 60 for N2 gives us a degree of freedom of 112. So step 3 is always compute the p-value. So again, here's our t distribution on degrees of freedom is 112. All right, so here's our center, and we get 1.15. And take a look at the alternative. So notice, based on the alternative, we have that this is greater than 0. So we know this is going to be an upper-tailed or a right-tailed test. So we get this, and we shade that region there. All right, so this is our p-value. Is that tail right there? So that's going to be TCDF, lower bound, 1.15, upper bound, E99, degrees of freedom is 112. All right, so second distribution, menu option 6, lower bound 1.15, comma, E99, comma, 112. All right, so we get 1.1263. All right, so step 4, we make a decision. So 0.1263, and we want to compare that back over here to our alpha level, which is 0.01, and we can see that our p-value is way bigger than the alpha level, so we fail to reject. All right, so since we fail to reject, again, all we're saying is that there is not enough evidence to support the alternative hypothesis, and that the amount of difference between the 14.8 and the 8.1 between the experimental and the control group is just due to innate random variability within the data set. Okay, so yeah, that's about what, 6.7-ish, something like that. So that 6.7 is innate random variability. So our formal conclusion, we can state that at alpha equals 0.01, the data indicates that there is no difference between the mean improvement between the experimental group and the mean improvement of the control group. All right, so as you may have noticed that each one of these is an upper-tailed, lower-tailed, and a two-tailed test. So 3 examples. So there you go. I hope you enjoyed.